We're here today to really do a podcast on the best casting. Best casting, of course, what does it mean? And when we were getting ready for the announcement of this year for the Horseman's Act, a lot of the judging groups, including this one, wanted to add 3 more pages to the announcement to tell you what we meant by the best casting. And it seemed to me that it would be much better for us to do a podcast and just talk about what it is that we're looking for in terms of the competition itself, but also the reason behind casting steel and why we're using casting. So I wanted to start out at least briefly before John jumps in and corrects me that the best casting thing was really goes to the heart of the cast and steel competition because from the very beginning, having worked in the casting industry, we make real steel. All the steel you use originally was cast somewhere. They did other value-added things to it like heat treatment and grinding it into shape, and they may have done other things like forging or rolling it, but all of it was cast. And so I knew from our background that you could make anything as a casting that you made with other products. And if you did it cleverly, you could actually make it perform. And so one of my core goals in the cast and steel competition was to make these really traditional blacksmith products that people knew had to have full properties to function and get students to make them and demonstrate that you get real steel properties. And my idea with that was that it would help convince the university professors that cast steel was not cast iron, that you could weld it, that you could hit it, and it wouldn't shatter, but also to give the students the experience that this is really a capable process that's creative. So on the one hand, I really desperately wanted them to really explore castings and develop the full properties. On the other hand, I have a Boy Scout background and I want them to cheat. And I want them to cheat in the sense that they are clever enough to use things that we had not thought of. And so we weren't trying to restrict or limit what they could do. And so my goal, and I've talked to John and Jack and Joe about this in the past, is that the requirement as far as I'm concerned, and they get to be more specific than that, but as far as I'm concerned, is that you were clever enough to really add value with the casting process. So how did you add value with the casting process? And we want the maximum value you can extract from the casting. So it's really difficult to see how if you just cast the pommel on a forged sword, that was really using the casting process very creatively. So it's not that because we don't have a minimum requirement for how much casting you do, it doesn't mean that we're indifferent to it. It just means that you're the one who's supposed to figure all of that out. But we want to talk a little bit about the experience we've seen, what the limitations and what some of the challenges people who've competed have had in terms of their castings. And then how do we evaluate the casting? What role does the technical report play? How much of the best casting is limited by its performance or its fit and finish? What is it that you, who've been really key judges for the best casting, what do you look for and what have you always wanted to tell students that you don't think they know, understand, or paid attention to?
If I can start off, first off, it's a challenge. These are not easy castings. We did not intend it to be an easy casting. We want it to be hard for you to make. So if you pour a block and forge it into a shape, yeah, you poured a casting, but the casting part isn't hard. We want to see the challenges that you overcome when you make a casting.
One of the things I found it from the first competition was the challenge of making something that's difficult to make as a casting was something that the students really valued. They felt like that was really a challenge that they could overcome. So, Joe, what have you seen in the castings that you've evaluated, and what are some of the things you might want to tell the students that would be helpful to them?
So when I look at the best casting, I'm really looking at the whole process. So I'd like to see the concept that brought them to the design that they're using. I'd like to see that they learned and considered different casting processes. Ultimately, when they come down to make the casting, they might be like the rest of us in the real world who say, all I have is this process available to me. But I might look at the part and say, this would have been easier to do in this process, but I'm going to do it in this harder process. In the last competition, some teams made that very tough sword geometry in sand, which going in I thought was maybe almost undoable. But they came up with some creative approaches and made it work. So I think that that picture and that picture is not only the part, but it's also in the technical paper, what they're discussing that they did or didn't do, and in the video. And failures happen. I think it's a good thing for teams to say, I tried this and it didn't work. So I moved on and thought differently and tried something else.
So, Jack, what's right off the top of your head things you want the students to know?
But I think we were looking a lot at aesthetics in terms of how you want the best casting to be a good-looking casting. So surface finish and design, and really a big factor was how the casting process allowed you to implement the design and the form that you wanted to end it up with. You know, because sometimes you'll get like you said, you could cast an ingot and forge it, but there was some competitions where very simple form was cast, and then a lot of machining was added to add intricacy in terms of shape and function. And in my mind, that tends to discount the best casting quality. I like to see as much of the final form imparted through the casting process as possible. But
I agree. I think if you cast the block and you do the forging and machining, you've kind of missed the point of casting, right? So it's important for the teams to understand that the advantage of the casting process is to minimize that additional finishing work that has to be done.
Sure.
And there's a lot of really aesthetically beautiful pieces that get implemented with value add that's not casting, like the etching and things like that, which I think is really cool. But I tend to favor those designs where they're able to cast those features in as opposed to value add them afterwards as part of the casting process. And then I will say in this last, I wasn't there for the actual competition, but I thought from the technical report point of view, the Youngstown State approach where they decanted the riser as part of their process to, minimize distortion on the end piece and everything was really creative, and that would influence me, to.
Yeah, so if I understand, and I think this is all good input, number one, that in castings, we're really selling geometry. We're selling information. We fill it up with steel, and we want the steel to have high performance and all of that. But if you're not utilizing the capability of the process to create the unique geometry that gives you a benefit, you're not really getting the full benefit of it. And then, of course, what you said at the end, Jack, which I was hoping somebody would bring up, really looking at unique approaches to castings, because we're not making a commercial product. We're trying to optimize that particular item. So it's not that we need to use some commercial or common practice. We can do really clever things with chills or specialty sands or all kinds of tricks that we use in the foundry to optimize a process.
Or something like in the sand process, unique core layout, using extra cores to impart unusual geometry, backdrafts or undercuts or things like that. That again, you would achieve through the casting process as opposed to value-added post-processing, but to show the flexibility of the process, or to demonstrate the use of possibilities of the process to, affect the final form and design.
Sure.
Yeah, I think there was an example in the last competition, one or more, where the teams cast the blade out of one material, and then they cast the handle and pommel out of another material, but they cast it integral to the blade. So they went back in and used the blade as an insert and cast around it. Again, really nice creativity. Gave it a very solid mechanical bond, which ultimately helped them out in the performance part of the competition.
Yeah, and I like to see what they're learning from their foundry partner as well. To me, it's not just what the students can come up with, but what are they learning working with their foundry partner? There's different ways to mold things. You could pour in different methods. You can heat treat differently. What material selection you use. And also, like Jack and Joe were both saying, any additional, I'll call it extra credit things you do, like maybe 3D printing. It's becoming more typical now, but do something a little different with it. Can you do ablation casting, which I don't think we've seen that yet. But there's many different things that people can try and say, oh, look, we were successful. It may or may not work. And remember, all three of us that are here, we've been making castings a long time, and we've all had a scrap casting or two in our background, right?
One or two.
One of the things I think that you touch on that I think is really unique about this competition, and when I talk to people like the tech school that Joe had me talk to, they think it's sort of closed-ended for the students to figure out. And I had to tell them that no, when we did the African spear, we had teams calling tribes in Africa to get information. And when we did the Celtic leaf sword, we had them call the British Museum. And so even in the casting technology side, they should really feel free not only to reach out to their industry partner, but to anybody on the call or anybody if they have questions or they want to try and explore, brainstorm some alternative approaches, because we're really not restricting them to use just their own creativity. We want it to be like a real industrial project where if you can find somebody smarter than you are and steal their ideas, that's the optimal solution. And so that's what all of us have done all of our careers, find somebody smarter than we are and steal their good ideas. And to me, that's something that's unique about the competition, is we're not asking them to do the just literature research and come up with their own creative thing like they're on a PhD candidate. We're really interested in them doing it the way you would in industry, which is calling the smartest people you know and making that network connections, whether it's the AFS chapter or the Steel Founders Society local member or whoever. How can I do this smarter and how can I do it better?
Well, we had an instance this year where we worked with the University of Tennessee, and we didn't pour the alloy that they wanted to pour it out of. So I called a foundry I know that does pour that alloy, and they actually had it poured there. So they worked with two foundries. I think what they got out of that is they learned that not every foundry does everything.
I think that's valuable. One of the things I think would be useful, though, is even in traditional foundry practices, we tend to be relatively indifferent to some of the micro shrinkage, and yet with all the little thin things we make, people want to make sure they're well fed. And if you feed them from both sides, you can put a hole in the middle of the casting. And so I think one of the things that would be useful is when they have their rigging is to really think through and talk to someone to make sure they get directional solidification, rather than having something where it looks from a modeling standpoint like it's well fed, but then they have some place in the middle where there's no thermal gradient. And if you have no thermal gradient, you're going to have microporosity. And when you polish it, it's going to show up. And so I know all of you have seen that on some of the things. The other thing I wanted to really spin back around to, though, is we had a number of failures in performance. And if it fails in performance, no matter how beautiful it looked when we did the initial evaluation, you're not going to get credit for a good casting. And so if you have a failure, that's problematic. And so one of the things that a number of people talked to me about at the last competition was requiring NDT. Now, I'm reluctant to require NDT, but I think NDT would be useful. So when I took some of the broken swords and I'm refinishing what's left of them, some of them had a number of cracks, and you began to see it when you polished them. So when I talked to David Baker and Ben Abbott, they agreed that when you polish the sword, that's a really helpful quality check, because if you have a crack, you can often see it then. What would you suggest to the students that they do in terms after they have it? How much do you think they should do testing? You have a risk you'll break it if you test it, but if you break it when you test it, it might have broken in the competition. Should they do magnetic particle testing? What do you think they ought to do in terms of trying to grapple with making sure it's going to perform?
At least part of, in the spirit of the scout, I guess, is they might imagine what kind of testing we're going to put it through.
Sure.
Make a couple copies and give them hell and see what happens. I mean, that would be some nice practical testing of it. And beyond that, with the availability of the technology we have now for NDT, have it X-rayed, do mag particle, know that you have isolated porosity or you have some cracks that should be dealt with. If you have cracks that should be dealt with, then that's another opportunity to learn more about the processing of castings, upgrading, if you will, to take care of those and have a better end product.
So there's two common problems that I want all three of you to weigh in on. One is, of course, when we have a critical casting that has to be made to a particular deadline, some of the foundries make 2 or 3 of them to make sure they can pick the best one out, and that lets them play around with the other ones in terms of processing to make sure the processing works. And that's something you were saying, Joe.
Yep.
So that's one thing. The other is scheduling. We announce it in August, but if you haven't finish the design by the end of January, and you're expecting the foundry somehow to fit you into their schedule between January and March in February, you could really be in trouble. So if you wouldn't mind discussing briefly both the capability of making multiple pieces, but also the scheduling. How early should you do things? What kind of schedule do you think would be appropriate? And of course, if you don't schedule early enough, you don't have time to have the early failures and recover from them.
So far in the multiple years that we've sponsored a team, everybody has been kind of that pretty close to that bad description you did, where we've come right down to the wire, cast parts at the last minute, air freighted them in some cases back and forth for finishing. So it's really, and we try to shepherd what we can, but certainly that team and that advisor really needs to work on shepherding that team and set some event timelines and say, okay, by here we should be at this point in the project. A good portion of the papers that I reviewed last year did make multiple copies. Some made, one team I think made 12.
Oh yeah, it's pretty common because the foundry likes to have one, the university likes to have one. It makes sense. But one of the things that I've thought that we ought to at least informally suggest is that you really want to certainly have your final design for your first cut done by Christmas.
So it should be poured by Christmas.
Huh?
They should be poured by Christmas.
Yeah.
And the reason I say that is because a lot of foundries shut down that week, the same way the students have their vacation shut
Yeah,
down
yeah,
or holiday weekend. They think, oh, we'll go to the foundry while we're on break or something, maybe get it poured. It doesn't work out.
sure.
I told the teams this year when we were leaving the contest in April, I said, get your teams together now. Figure out who's going to do the design, who's going to do material selection. I said, and then when you get the product you're going to have to make, you have a jump on it. Those teams that are waiting until school starting in the next couple of weeks to start going are already behind a few of the teams.
Yeah, that's one of the things. If you look at SpaceX or Anduril or the more modern manufacturing people, is they intend to make an initial part, break it, so that they can optimize and take. That allows you, if you give yourself enough time, you can have a more radical design, because instead of being conservative in your design, you can do the radical design, break it, and then fix where it broke so that you can actually have the optimum performance.
Yeah. Joe was the swordinator this year. He broke 4 or 5 of the swords himself. So he would know more about that than anybody.
Yeah, yeah.
Yeah, that was certainly interesting, and I was really happy to have the opportunity to be one of the testers. And it was interesting. There were certainly swords that I picked up that I knew weren't going to survive some of the tests, and it kind of harkens back to the conversation just a little bit earlier about the teams using some imagination about what we might do in testing, and doing some things with their sword, or their in this case the horseman's axe, to simulate what they might think happens, so that they're better prepared in their design iterations to have something that survives.
Good.
Yeah, and definitely look at the material. Okay, remember, we are cast in steel, and I'm not going to give you any credit if you pour it out of titanium or, some other material. It's cast in steel. Yeah, you might get a good product, but to me, the emphasis is on the steel as well.
Yeah, well, one of the interesting things is it's not really clear to me, given the limited number of tests that we do, that, I mean, people, especially the metallurgists, agonize over what material to use. And I mean, anything beyond a 1040 steel would probably work fine for the things that we make with a limited number of tests we do. It's not like we're going to be going into battle against 100 people and smacking 30 in a row or something. I mean, it's pretty straightforward. And of course, that does allow some of the teams to do things that reduce the risk, because since you're not that cost sensitive, you could look at something like an air-cooled martensitic stainless instead of a quenched and tempered high carbon steel. But both would work, both would be good, but you could actually look at things like that if the foundry is a partner and your capability allows you to do it.
I get asked several times coming up to the contest, what are the tests going to be? What are the tests going to be? They want to test them first. And I'm like, I can't share that information with you. You have to figure that out.
Yeah. Yeah, I mean, that's been a constant thing. And of course, why I resist that is I don't really want, especially the professor, to try and help the team design to really be successful at the test, instead of saying this is an item that has a number of different uses, and the test will be appropriate to what the item was designed for. So you need to design it for the maximum utility, not just to be good at a particular test. Anything else you want to tell the students? One last round. What's one good idea you've had that you think no student has used yet, or you think if they did that, it would give them a real benefit in terms of the competition?
Well, you mentioned the rise ring and having shrink in the middle. When we use magma, yeah, you can find shrink easily, But when we're looking at some of the more difficult parts to cast, you have to look at your metal flow and your gating system. To me, you can avoid a lot of problems with porosity if you look at your gating system and get a non-turbulent. It's confusing, but I like to say fast but slow fill. You want high volume but low velocity.
Yep. Cool. Joe, what would you give them?
I think what John started talking about on material selection, the thing that I think they could learn a lot about is you can skin the cat a lot of ways. You don't have to have, you're going to do some research and they're going to say, this sort of an item is made out of this material. And really what you would like to learn about are properties, and there's a lot of ways to get the properties.
Yep.
So it's
and that would be
imagination after the casting.
And that's one of the places where they could really reach out and talk to people, especially people in the foundry that they're working with, because they will have had experience with products that were critical that needed high performance, and they'd have their own special mix heat treatment to try and do that kind of stuff. Jack, what is on your mind?
Couple things. Number one, I think the point you made about, I'll just generally turn networking. They should do networking early. We've always kind of expected that to be a byproduct of the process.
Yep.
Going to the competition and meeting people, but networking early to get those ideas and to get input early in their process may help them be more successful. In terms of NDT, at the very least, I'd discuss with the partner foundry what's available there. I know the shops that I've worked in all had in-house NDT of various types or easy access to outside NDT. So finding out what might be available and then, working with that. Or as John said, he talked about another shop pouring a different alloy. The shop they're working with may know another shop that could help do NDT if that was desired and work that network. In terms of unusual processes, several times I've thought that centrifuge casting applied to some of these parts would be quite interesting. And I realize that's a homer statement coming from the centrifugal world, and it's not
yes,
all that
is.
easy to pull off. But it's not all that easy to pull off. But depending upon the project,
that could be interesting.
It could be. Personally, I thought making the Halligan bar as a centrifuge casting it horizontally, feeding it with the sprue down the center, patting around the T-junction so that you're sure you're solid and have some extra material to machine back, but to get the force on both ends of the tools to get good feeding would be a really cool thing to do. Yeah. And I did suggest it to some people, but they didn't buy it.
Oh, that would be cool. That'd be, and I really do think you want to look at unique things. And so one of the things I don't think people really realized is that cooling rate is really the driving force to give you good properties. So it's not, when you're looking at sand foundries or even investment castings, if you have critical sections that need to have the properties and it's at a junction, getting it to solidify fast and cool fast when you're doing the heat treatment optimizes your mechanical properties, both ductility and strength.
Yeah. One other thing, Raymond, I think we'd be remiss if we didn't mention is the funding for this project at the schools. Yeah. Don't be afraid to ask your partners if they could donate the metal that you want to melt or something like that. Don't be afraid to go to the local AFS chapter and say, hey, could we get some funding for the trip or anything like that? It's available out there. You just need to go ask. And I think that's part of this is a learning experience, stepping out of a comfort zone a little bit and introducing your people you don't know and asking for things.
Oh, absolutely. Yeah, I mean, both the FEF chapter, the AFS student chapter, the local AFS conference. You can even, and we've had those calls before to us. And if you call me, I know the people in your area that you could talk to that might be willing to write a check. So yeah, I think that's a great idea because you certainly don't want them to make bad choices because of some incrementally small amount of funding. That's not a good outcome for the students or for the competition. So certainly agree with that.
One last thought is on team makeup. Is as the teams are putting themselves together, it'd be great to have a whole bunch of engineers, but you want to have a good paper and you want to have a good video, and so you might reach out and get some other disciplines involved, and it's ultimately it's great for the entire process because they may end up saying, wow, the foundry would be a great place to work. Even though my degree certainly wouldn't have steered me there, but after being part of this team and causing this to happen, I now have some interest in that.
Yeah. Oh, yeah. That's one of the things they found at University of Northern Iowa. They've been getting the computer students to come over and do some of the Industry 4.0 stuff for them. And that once they get involved in actually hands-on equipment and seeing how it works, a lot of them decide they're really interested more in manufacturing than sitting behind a desk and doing programming. So, yeah, it's really fun. Any last thoughts?
Yeah, for those students who have never seen metal melted and poured before, once you see it the first time, we got you.
Along John's thoughts, maybe a trip to the foundry before they design their part. If they've never seen metal poured, maybe seeing their casting poured shouldn't be their first observation. If they could get a foundry tour and see just regular castings being poured, it may give them some appreciation that would help inform their design process.
I think that's a great idea, and certainly we at Steel Founders Society would be happy to help any team find some place to go visit. And if they actually just take the picture of the horseman's axe with them and talk to the people who give them the tour about what they think about how you would design it and what are some of the challenges, that's the first networking thing I'd do if I was on the team, because that way you'd get immediate feedback and you'd get them engaged so that they could really become a resource for you as well. So that's a great idea, Jack.